Viewers, you are welcome to MA Mathematics channel. MA Mathematics channel will serve you the mathematics that you need for your basic schools and senior high school. So today we are to take another lesson under three-set problem. So if you are new in this channel, you are not subscribed, try to subscribe and like my videos. Anytime I upload a video, you can have access to it. Let's go into the lesson. Today we are going to look at three-set problem. And three-set problem, like the last lesson we talked about two-set problem. With three-set problem, we have three different sets that have relations. We have three different sets that have relations. So in that case, I have, look at the flip chart on the board, pasted on the board here. I have three sets, that is the regions of three-set problem. We are going to look at that. And we have P, Q, and R. They are the subsets under the universal set U. So we are going to have, you can see I have labeled each of the regions from region 1, 2, 3, 4, 5, 6, 7, and 8. So we are going to look at what each region represents and how to apply each of the regions to solve problems under three-set problem. Before we could look at much application to solve examples, you must be able to we are going to look at, use this one and come out with the De Morgan's formula for three-set problem. If we are able to do that, we can go ahead to solve more examples. So from here, region 1 represents the intersection of P, Q, and R. And we have region 2 represents P intersection Q only. And region 3 represents P intersection R only. That is region 3. We have region 4, which represents Q intersection R only. Is here. We have region V represents P intersection Q prime intersection R prime, or complement. We talk about R complement, Q complement, and R complement. That will represent V. Or you can also see that it represents P only. Good. And VI represents, VI represents Q only, which is written as Q intersection P complement intersection R complement. And VII represents R only, which is written as R intersection P complement intersection Q complement. And we have VIII. That one represents P union Q union R union R, all complement. All complement means elements that are found inside the universal set, but it's not in any of P, Q, and R, but it's found in the universal set. So that one represents region A. Good. After this one, want to look at something. When you are asked to find only P, all these regions under the circle representing P is equal to P. So we sum everything here. That is 1, 2, 3, and 4. And 5 rather, sorry. Give us region P. And we have N of Q. Represent all the regions that are under the circle representing Q. I, V, and VI, as we have seen here. And we have N of R. Represents the regions. We have region 1, 3, 4, and 6. Good. After doing that, we look at the intersection. The intersection of P intersection Q means that if someone is in P, or the element is in P, at the same time is in Q. So it represents region 1 and 2. P intersection R. The element is in P at the same time in R, I and II. And Q intersection R. The elements that are in P at the same time are. Good. And the last one, when you observe from here, you realize I is here, I is here, I is here, means I run through the three of them. In that case, we could say that P intersection Q intersection R is what? I. That is what was represented here. Good. From this point, realize that when we come to this side, when you are being asked to find P union Q, you have to add all this region. The region, this and this. Or you add this and this. But those that are the same, you ignore those ones. Good. And Q union R. The same thing. The regions in Q and the regions in R. P union R. The regions in P and the regions in what? R. Good. And we look at how we now want to find P union Q union R. So all that we will look at, write all the regions that are found in all of them, but that are found in P, Q, and R. So that is why we have Roman numeral 1 up to Roman numeral 6. And we look at the universal set, N of U, which one represents all the regions. So we have region 1 up to region 8. But the simplest way of writing this one, you realize that region 1 up to 7 is P union Q union R. So that one represents, so you just write P union Q union R plus your region 8. Good. After doing that, but there is a condition here. In case the region 7 is region 8 rather, is 0, then we will have P, we will have N of U equal to N of P intersection Q intersection U. Good. After taking you through all this and this one, for you to understand, this is the concept of three, that is behind three-set problem. De Morgan's formula, De Morgan's have many formulas and a set theory. There are many, but this is one of them and a three-set problem. So we have N, P union Q union R. So you add N of P, Q, and R, and subtract their intersection. You have this P minus Q, N of P intersection Q, P intersection R, and P intersection Q intersection R, plus their intersection. So now, why do you have to subtract? Why do you have to subtract? If someone may ask that question. You have to subtract because you have taken P and the regions representing P, the regions representing Q, the regions representing R. All these regions, some of them are repeated. For that matter, the subtraction of their intersection takes away the repeated ones, leaving only a single one. As is being repeated, and that's why you have to also add this one because you have subtracted this and this and this, and the I is inclusive. After the I is inclusive, so you add it back by what? Add N plus N of P intersection Q intersection R. So today, I've taken you through the introduction of three-step problem, and we have come out with the De Morgan's formula. In the next lesson, we shall use this formula to solve examples. Thank you very much. If you are new, try and like my videos, subscribe, and share with your friends, and let them also have access to these videos. Thank you very much.